John Drenick. I am a software developer with Vibration Research. I've been worked with the company for about 14 years. Spent majority of that time working on VibrationVIEW. Done a bit of work with ObserView as well. And today I'm going to discuss the new features coming out in VibrationVIEW 2022. So glad to see you all here. I've been working support for a good number of those 14 years as well, and I've recognized some of the names I see, so welcome. And I appreciate the opportunity to talk with you, and please let us know if you have any questions. We enjoy hearing feedback from our customers. That's how we develop our software, and it's very helpful to us if you let us know what works for you and what improvements can be made. So let's get started with the presentation. So first we'll go through the changes to multi-loop with phase controller, the new feature. For the 10500, I'll be discussing tripod outputs for a little bit, sign data reduction, and sign output selection. Those are some of the key features of the 2022 release that I'd like to go through. There are some more smaller items that you'll see in the release notes when they come out, but these are the main items. All right, multi-loop with phase control. This used to be the dueling shaker feature, if you're familiar with that, on the 9500. We've taken that capability and expanded it from 2 control loops to 4, and I'll explain what this feature is for those that aren't familiar with it. But we expanded it from 2 control loops to 4, renamed it to be multi-loop with phase control, and we moved it exclusively to the 10500. There's additional CPU requirements that make it best if it just works on the 10500. The normal 9500 multi-loop features, 1 box per control loop, independent control, that remains unchanged. So sign multi-loop with this is essentially, this feature allows us to control the magnitude and phase between control loops. So we can set specific phase requirements between the different control loops. As part of that, we also did enable multi-loop control for sign. We can do 3-axis up to 4 control loops. So a typical use of that would be a 3-axis shaker, XYZ, possibly a tripod. Another example is a 4-poster system. You can control the loop, the phase for each loop per schedule level, and I'll show you that shortly. And there are 3 different control options: magnitude and phase, magnitude only, and equal outputs. So with magnitude and phase, what we're doing is we are tweaking the output so that the magnitude and phase are at the desired levels across all the control loops. So if we had a force of phase of 0 degrees across all the control loops, the control channels would be perfectly in phase and at the exact same magnitude. And I'll show an example of that shortly. The magnitude only option doesn't get used very often. Probably the most likely use for that one would be for a system that is tightly coupled, that you have multiple shakers that are very tightly coupled together, and the phase control just isn't giving you the results that you want. So there we allow the phase to wander as it needs to, and we just ensure that the magnitude is the same between control loops. Equal outputs is essentially just a software T. So the exact same signal goes out of the outputs. And with this feature, we can do averaging and extremal control on any of our 512 possible channels on the 10500. We do require that one of those channels be on the primary control unit, but the rest of them do not have to be. And course, we do not recommend using too many channels in an average control, but if you have a need for that, we can do that. So let me go to the software here and walk through it. So I'm pulling up a predefined test here. So one limitation, I guess I would say, with sine is that we do require that every profile or every loop has the same profile, the same amplitude and frequency range. So we do enforce that. If you would make a change here, for example, change that to 2G peak. When I switch to the y-axis or the z-axis, it is the same. So you would define your profile as you would for a normal test, and then to enable multi-loop support, you would go over to the Channels tab, and you would select the different control loops that you want enabled, and you would select your control option. So what I have here on this test, I have 2 sweeps, and on my y-axis, my second control loop, I am forcing that the phase between the second control loop and the first is 60 degrees for the sweep up and 45 degrees for the sweep down. And for the z-axis, it's 120 degrees for the sweep up and 90 degrees for the sweep down. Also note that when I'm selecting my axis here, I can go to my Channels tab, and I need to select the appropriate control channel for each loop. So for loop 1, my x-axis, I'm controlling on channel 1. My second control loop, the y-axis, I am controlling on channel 5. And on Z, I am controlling on channel 9. So I'll start running my test now, just running in demonstration mode. So here you can see that these are my 3 control channels, and you can see the phase difference between the 2 of them. Got one at 60 and the other at 120. And once this reaches the end of level and starts sweeping down, you'll see the phase between those channels change. And with sine, most of our tuning parameters are the same for all of the control loops. There you can see it, it shifted, and the phases as defined. Now, most of the time, most of our customers that are using the existing dueling shaker feature, they have multiple shakers in parallel, for example, and they're testing a product that doesn't fit on one shaker. So they're using 2 side by side to support the product. For example, maybe a long cylindrical tube or something underneath 2 shakers, or just a large product. Those are some typical uses that we have seen for the dueling shaker, where you're required to have the magnitude in phase to be synchronized. And of course, an XYZ shaker situation as well. You do want to be careful when you're doing XYZ with sine. If you're doing multi-loop, of course, you're just going to basically be drawing circles in the air, like you kind of saw with the scatter plot in my lower right corner there. And that if you run all 3 axes at once trying to accelerate your test, you may end up not actually testing the axis that you are intending to test. So I guess something to think about, and check your specs if you are trying to accelerate a sine test using multi-axis. Back to the presentation here. Yes, this is only available on the 10500. Also, the COLA output on the 10500 is the same BNC as the fourth output. So if you are using all four of your outputs, like a four-poster system under a car, for example, you do not have the ability to use the COLA, at least directly out of VibrationVIEW. All right, on to random. So in random before, we did have, like for example, in the 9500, we did have multi-loop control, multi-axis, XYZ, four-poster, that sort of thing. What's different now is we have the ability to control the magnitude and phase between the control loops. So with random, we have the magnitude and phase, magnitude only, and equal outputs that I talked about in sine. Again, magnitude and phase would be the primary one that you would use for controlling in magnitude and phase. Magnitude only would not get used very often. Independent control is what we've always had. Each control loop runs independently with no fixed phase relationship between any of the control loops. Once again, you can use any of the 512 possible channels as averaging or extremal control, but you do need to have one of the control channels on the primary unit. Switch back over to VibrationVIEW and pull up a test. So what I'm showing here is that each control loop can have a different test profile. Normally, I don't think they would be this different, but I'm just trying to show the feature. So again, I can switch between my axes, X, Y, and Z, and I can set my table as desired with different tolerances, different abort lines, whatever the test requires. Of course, the sample rate, number of lines, that's common for the test. When I go to my channels tab, I would also need to enable my control channel for the appropriate loop. So again, for X, I'm controlling on channel 1, Y on channel 5, and 9 on the Z axis. And then I'm enabling my 3 loops. You don't actually need to enable all 3 loops. We can enable just one at a time. I'll show you that shortly. So let's run my test. So you can see my different demand levels, RMS levels for each axis, each control loop. And as we're coming up to level, I just see my IDOF kicked in there. So I have my nice smooth control lines. And you can see I have a fixed phase now between channels 1 and 5 and channels 1 and 9. Remember, those are my control channels. So this test has fixed magnitude and phase. Now, with a random test, fixed phase means something a little bit different than it does in sine. What we're saying with the fixed phase relationship is that for each bin in my FFT, there's a fixed phase relationship. If you would look at the waveforms, they wouldn't necessarily look in phase. Just show you. So, there is, it's not as obvious. The phase relationship can't really be seen in the time domain, But if you look at my transfer function phase graph, you can definitely see the phase relationship at each bin. If I would think this will work, just went off script here a second. Yeah, never mind. All right, so let me change this, and I'm going to go back to independent control so you can see the difference. So now as my test comes up, you can see that my transfer function phase between the various control loops has no real relationship at all. It's just everywhere. All right. So again, the phase control is only available on the 10500. For the 9500, you would not see that. You do not see this drop down here on the channels tab giving these various options. All you have is independent control. So, but you can still run a 3-axis shaker with a 9500. And again, same is true for the Cola. It's not available on a 4-loop system. All right, for shock, there's actually not a lot of difference in shock. We did get it working with the 10500, so you can use the various outputs. You could only use the primary unit for control. Excuse me, the outputs from the primary unit are the ones that are used for control. We don't use the outputs from any of the other units, but you can, of course, enable up to 4 control loops. Again, the 3-axis, the 4-poster system as examples. One change we did make is we do allow multi-loop classical shock now, half sine, terminal peak, those types of pulses. And SRS and UDT, they work as they did before. So as far as phase control goes, with shock, we are, of course, controlling to the pulse. And to the extent that the demand pulse, to the extent that they are in phase between each other, the shakers will be in phase. That's the way that it has been in the past as well. So classical shock, we do require the same pulse on all control loops, and each loop can be enabled separately for individual axis testing. And I actually wanted to show that in random as well. So since I'm still here, I'll just show that. I go back to my channels tab, and I'll just enable my Z-axis. And as I start running my test, you can see in my control buttons the demand for loops 1 and 2, the X and Y axis are 0, and the only real signal I'm seeing is on the Z axis. So that works with sine as well. You can just enable each loop individually. All right, so let's pull up a classical shock pulse here. So it runs as you'd expect. Nothing too surprising from here. But like in random, what I can do is enable just I'll do my Y-axis. and I'll just be running my y-axis. So the way you would define the test is probably as you'd expect. I define my pulse, and like I said before, this is fixed, so that's the same on all loops. So if I would change this to terminal peak, for example, it has changed it on all the loops. So, and then I would go to my channels tab and enable the control loops that I want and set my control channels. So, as you would expect. For a UDT test or a SRS test, there really is no difference, so I won't be walking through that. An FDR, so again, similar to shock in that there's not a lot of difference other than it now works on the 10500 with the, I guess I do want to make that more clear. For the 9500, if you wanted to have 3 control loops, you needed 3 boxes, and you use the output from your first 3 boxes or 4 boxes to connect to your shaker. For the 10500, you only use the outputs from the one 10500. There are 4 outputs on the 10500, and you would connect each of those outputs to a different axis or a different poster on your shaker system. So that is the primary change in FDR, the move to the 10500. Again, the phase control is there to the extent that your source VFW files are in phase. And we do ensure that the sample by sample synchronization between the different VFW files is there, but if your VFW files are not in phase deliberately, for example, then your shaker will not be in phase, but we are controlling to the waveform. One change that we did do is that in prior versions, you could have, each loop could have a different VFW file. And you can still have different waveforms for the different control loops, but now those different waveforms need to be combined into one VFW file. So you would have, like a 3-channel VFW file, and you would control channel 1 or loop 1 on channel 1 from the VFW file and so on. I'll show that shortly. All right, so if I pull up my FDR test, see I just have the one VFW file, and it is the same VFW file for all of the different loops. But notice that my demand channel is changing. So for my Z-axis, I am controlling on channel 3. You can see the difference in the VFW file channels up in the top here. And then for my Y-axis, I'm controlling on channel 2 from the VFW file, and from X-axis, channel 1. Now, if you have your existing VFW files, you can combine them using ObserView 2022, which will be coming out shortly. So this is what my VFW file looks like right now. So I have my X, I guess it's labeled here, channel 2, and Y. But I got my 3 channels, and these are what I will be using as my demand for my FDR test. To combine channels, you would go to the file menu. There's this command line tool in ObserView. In a future version, this will be a little more built into the UI, but what you would do now is you would select multiple files. They would need to be the same sample rate. The ones that I selected are not. Oops. And then you'd select the overlay option. And then you can either trim the excess or zero pad the files. Likely if you were doing this for real, they would all be the same length anyway, since you were already using these for an FDR test. But if they were not, or you're developing a new FDR test, you could either trim or zero pad your VFW files. So that's how you do that. Not exactly certain when the ObjectView team will be releasing the software, but I believe it's in the next couple weeks. So back to VibrationVIEW. Again, we would go to our channels tab to set our control channels for the different loops and enable which axes we want to control. So as I run my test, if you're familiar with FDR, you'll see that it's working like a normal FDR test. One thing I should also point out, if you go to your configuration and parameter, sorry, the wrong tab, the outputs. Here's where you can set your loop labels. So I've set mine to X, Y, and Z. If you had a 4-poster, you could label it, right front, whatever, or drive 1, drive 2, drive 3, whatever makes sense for your system. So those labels are what show up at the in this drop box down here. All right, that is it for the magnitude and phase control in the multi-loop on the 10500. As part of moving multi-loop or enabling multi-loop on the 10500, we took a look at the logic in our GeoBox, geometry box. And what that is that was some hardware that we had for a tripod system. It would take our regular X, Y, and Z outputs from the back of our box and do the necessary math to drive a tripod system. That GeoBox is no longer available. In any future tripod systems need to use a 10500. And when you have the appropriate key and set up on your 10500, you have access to the tripod settings. And that allows you to define the geometry of your shaker tripod. So you set the appropriate measurements on this tab, as well as the limits of your actuators, and then VibrationVIEW can enforce those limits and will not let you drive your tripod harder than it's allowed to. So those are our normal system limits are in the X, Y, and Z axes, and those still apply as well. But we have the additional system limits on your actuators. So the next feature I wanted to talk about is sign data reduction. So what we're doing here is we normally in a sign test, we have a frequency that we're controlling on, and we have our tracking filters around that frequency, and all of our graph outputs and such are based on that frequency. In this case, we are allowing an external system to drive that frequency. The reason you would do something like this, there's some industries that have a requirement for independent verification of your sign test by a third party, for example. So you could be running a sign test with one system and then use sign data reduction on second system to independently monitor with completely different hardware and still see the the data correctly. Another case where this can be used is if you need more than our, well, I guess 512 channels on a 10500 or 128 channels on a 9500, what you can do is get up to a second 128 channels or a second 512 channels for a total of 1024, and use your second system sign data reduction on your second system and have an additional 512 channels that you can report on. So another potential use case for this would be is if you need to run with a different vendor, but you want VibrationView's reporting capabilities. You could monitor the test with VibrationVIEW and generate all of your reports from VibrationVIEW. This is available on all of our hardware platforms, the 9500, the Observer, and the 10500. So I don't have a system set up where I can demonstrate that at the moment, but be aware that it is a feature that we do have where you can drive your test from a secondary system and get all of your reports and all of your data correct. Final thing I wanted to show is sign output selection. This is for the case where you have a multi-axis system, and at least in random and in shock, but you only have a single axis in sine, or single control loop. This is also only available for the 10500. I'm gonna pull that up a second here. Let me switch my hardware. All right. All right, so if I go to my edit test settings, see, I just have one control loop. I don't have my drop-down selection here. But if I go to the channels tab, I don't have my magnitude and phase options, for example. But I do have an output selection option. So right now I'm set to the x-axis. My control channel is channel 1. So I'm gonna run my test. It's gonna run just like a normal sine test. You'll see that channel 1 has signal, and that's matching my drive. So I'm running in my x-axis on my multi-axis system. But now if I would stop this test, go back here to my channels tab, and now I'm going to choose the y-axis. Now when I run my test, you'll see that channel 5 is the channel that will have signal on it. And I still my drive output, my one drive. Oh, and I made a mistake. I changed my output, so I'm running in a different axis, but I'm still controlling on my x-axis. I need to change my control channel to channel 5. And if I would have waited longer, the system definitely would have aborted saying no signal, and it would not have let things go too far. So now you can see channel 5 is my system with my channel that has signal on it now. So again, this is going to be a case where you want to say, for example, sequence your X, Y, and Z sign tests. If you would define 3 tests, one for X, one for Y, one for Z, then you could run a test sequencer. If you would go to test sequencer, and if we would add, just to assume those are my different axes. So now I have these two tests that would run one after the other. So for example, you could run your x-axis and then your y-axis and then your z-axis as a sequence and generate the reports that way. It's a way that you can do sequence your axes testing without needing to buy a full multi-axis system for sine. You still need a multi-axis in random or shock for this to work, just the way that it's configured. But all right, so yep, it's per test. Yep, I even forgot my own advice there. So we're targeting for VibrationVIEW 2022 an early March release date. So when it's looking like it's going to be available right now, we're basically done, as you can see. We're just running through some final checks and a couple more things to button up, but it does look like it will be an early March release date. The full changelog will be available on the website, of course. So you'll be able to see that when it comes out and see the various other smaller features and bug fixes that come along.